Hello everyone, we're in CS211 and in this video we're looking at some more Taylor series expansion questions, and we'll be considering three questions today. We'll be considering one from 2022 deferred, other one from 2023 Mbika, and the last one is from 2022 main campus test 2 paper. So to solve these three questions, we are going to make use of three equations or summations for the Taylor series expansion of exponential to the power x, cos x, and sine x. So these are the three formulas that are going to help us to solve these three questions. And to start off, we'll be beginning with the one question from the deferred test 2022, and it says develop a program that uses for loop constructs to implement the Taylor series expansion for the evaluation of f of x is equal to sine x to the power 10 and times tan x. So without wasting any time, let's just go straight into solving this question. Okay, so the first question we're looking at is coming from 2022 deferred, and we're looking at the Taylor series expansion of f of x is equal to sine x to the power 10 times tan x. And we already know our summation formulas. So we're going to start off with the design. Okay, first let me pause the video so that we move together and I write the summation formulas for okay, so now that we have of consideration, we can start with the design. So with this question, these are the two formulas that we are going to put in our use. So in the design, we are going to start off with some internal variables, which is, for example, the value of x. Okay, so we're going to say maybe x should be equal to pi over 4 in radians, which is equal to 45 in degrees. I didn't test something. I don't know what the value of tan 45 is. Okay, it's 1. Okay, so we can use this. So the internal variable for x will be pi over 4. Then we need to define the upper limit n, which is going to be equal to, let's say, something like 20 is all right as our upper limit. Then what we realize in MATLAB is that it's hard for us to get the summation for tan x. That's why I've just written the summation for sine x and the summation for cos x. But from these two, we can get tan x, because we basically know that tan x is just equal to sine x over cos x. Yeah. So with that in mind, we can move on to the for loop that is going to be that is going to get us the value that we're looking for, the evaluation for this problem that we have been given. And what we realize is that since we have been given these formulas, we basically have to be putting, like, if our upper limit is 20, we need to be moving from 20. We'll start from 0, 1, 2 to 3 to 4 up to we reach 20. So basically the value of n in this summation is supposed to be changing from 0 up to we reach our upper limit, which is 20. Then it stopped. So we'll be just basically replacing in here. We replace n when n is equal to 0. We solve what this is. Since it's summation, we add again when n is equal to 1. We add again when n is equal to 2. We add again to this up to we reach our upper limit 20. This is not an in-depth tutorial, but I'm going to share a video where we just do an in-depth tutorial of what we're talking about. In this tutorial, we're assuming that we understand the basic idea of how to solve these types of questions. So with that in mind, let's move on to the for loop. So we're going to also define our our variables for sine x and cos x. We are going to predefine them to 0. So we're going to say sine x is equal to 0 and cos x is equal to 0. Then we say for n is equal to 0 to 20, to n, since to n, our upper limit, cos x is equal to cos x plus cos x is equal to cos x plus -1 to the power n times x to the power 2 times n, and we're dividing all of this by factorial 2 times n. Then for sine, we're saying sine x is equal to sine x plus -1 to the power n just got disturbed for a bit. Let's continue. We're doing the summation for sine x, and we've said -1 is equal to -1 to the power n times x to the power 2 times n plus 1, all this divided by factorial 2 times n plus 1. So with that, we end the for loop. Then to get tan x, we just say tan, outside the for loop, we say tan x is equal to sine x divided by cos x. Okay. And then to get the answer, which I'm going to put in red, we will say f of x is equal to sine x to the power 10 times than x. And that's how you solve this question. So we have solved one question from our list of questions. Let's try to check what the second question is. Okay, so the next question is saying develop a program that uses while loops to implement Taylor series expansions for f of x is equal to exponential 4x than 2x to the power 3. Okay, this is a little bit different because we're not going to use a for loop now. We're going to use a while loop. We see that for our second question, um, highlighted here are the formulas that we'll be using, and here we see the question that we're trying to solve. And in our case this time around, we know that we're not going to use a for loop, we're going to use a while loop. So with that, let's try to look at the design. So we'll go again with our internal variables, but this time around we're going to switch things a little bit. We are not going for the upper limit and the value of x. We're not going to predefine them, but we're going to ask the user to enter them. So we're going to say x is equal to input, enter value x. Then for the upper limit, we're going to say input, enter value limit. And what other things do we need to predefine? Okay, we need to predefine the exponential. So I'm just going to say exp is equal to 0. Then I'm going to say cos 2x is equal to 0. You can just use cos x. Okay, let's just even use cos x. Yeah, but I just said cos 2x because these are the two inside for identification, but it has totally nothing to do with the solution. So you can use anything. You can use A or B, it doesn't matter. So I'm just going to say cos x is equal to 0. Then sine, I'm worried about space. Let me, cos x is equal to 0, sine x is equal to 0. I like that, so that we have a little bit of space. And the different case here is that we are going to need a variable that is going to work as a loop breaker. Since we're using while loops instead of a for loop, we need a loop breaker. And so we are going to say, and this loop breaker, we're going to call it count. Say count no, okay, let's call it n is equal to 0. And we're going to say while n is less than or equal to the upper limit, then whatever is inside this while loop should work. So let's put our calculations in the while loop. We're going to say exp for exponential is equal to exp plus plus 4 times x, all of this to the power n, and divided by factorial n. Then we're going to have sine. Okay, let's start with cos. Cos x is equal to cos x plus is equal to cos x plus -1 to the power n times 2 times x to the power 2 times n, then everything divided by factorial 2 times n. Then we move on to sine. Sine x is equal to sine x plus -1 to the power n times 2 2x to the power 2 times n plus 1, then everything divided by factorial 2 times n plus 1. With that, we end our, no, forgotten one thing. We are supposed to, the value for n is supposed to be increasing for it to reach up to our upper limit. So we're going to say n is equal to n plus 1. Then that is how we end our while loop. So when n will be equal to the upper limit, this is going to break. Then we're just going to have the solution. I'm assuming you know what I'm talking about. Okay, so what's next? We need to get tan 2x. So I'm just going to say tan x is equal to the cos the no, this is supposed to be sine x divided by cos x. Okay, like this. With that, we get tan x. Then to get our solution finally, we just have to say f of x. Did I do this in the last one? No, if you do this, you're going to get an error. Yeah, so maybe you do a dash like this. F underscore x is equal to exp times tan x to the power 4. uh, like this. Then you get the solution. And I think it's best you use for x, you use something like pi over 8. Yeah, use something like pi over 8 because we have a 2 here. Then if we say 2 times pi over 8, uh, we're going to get pi over 4. When we know tan pi over 4 is just basically equal to 1. Then what the other thing you are going to look at is e to the power 4 times pi over 8. Then this one, 1, here 2, and e to the power pi e to the power pi over 2 is something like 4.81, something like 4.81 if I'm not mistaken. Let me just confirm for a minute. What's the value? Yeah, it's something like 4.81. So if the user enters pi over 8, we're supposed to get something like 4.81 if you haven't made any mistake in the way you're writing your solution. And for the upper limit, for exponentials, you need to use a high upper limit. Maybe if you use an upper limit like 10, you're not going to get the value. But if you use something like 20 or 20 there or above, you're going to get the value. And that's how we solve the second question. Let's quickly move on to the last in our video. Okay, so let's look at our last question coming from 2022. Develop a program that uses for loop constructs to implement the Taylor series expansion for f of x is equal to sine x to the power 3 times exponential. This is a bit similar to, our last question, so we're not going to take that long. The only difference is that in this case around, we are using a for loop instead of a while loop. So when the 2022 paper, and the question is f of x is equal to sine x to the 3 times exponential. I'm not going to rewrite the formulas because by now I'm pretty sure we know what's happening. So we're going to go straight into the design. So design, we are going to use internal variables. Our value for x is going to be pi over 4. Basically easier to work with. Okay, no. Okay, yeah, we'll do pi over 4. It's basically easier to work with. And our upper limit is going to be defined at 20. I want to say xp is equal to 0, and sine x is equal to, don't leave a space here guys, please. So sine x is equal to 0. Then we get into our for loop. We say for n is equal to 0 to the upper limit. Then we're going to have our expressions for exponential. We're going to say xp is equal to exp plus, you might forget the summation, it's just x to the power n divided by factorial divided by factorial n. It's that simple. And for sine x, it's sine x is equal to sine x plus negative 1 to the power n times x to the power 2 times n plus 1 divided by factorial 2 times n plus 1. Okay, that. And we're going to say and f underscore x is going to be equal to sine x to the power 3 times e exp, like that. And that's how you solve this question. So we have basically done 3 questions. Basically, with that, I'm going to see you in the next video that we are going to do. And I don't know the next questions that we'll look at, but see you next time.